The first time I noticed it, I was standing in my kitchen holding a roll of aluminum foil. I was watching the bars on my phone disappear. I had wrapped the phone twice, set it on the counter, and called it from a landline. Nothing. Then I unwrapped one layer. Still nothing. I unwrapped the second layer, and the phone lit up with 4 missed calls in the span of a second. I stood there for a long time staring at a $3 roll of Reynolds Wrap. For years I had read the same line on every prepper blog and every survival forum. A Faraday cage has to be expensive. It has to be a metal trash can lined with cardboard. It has to be a $50 military surplus bag with a brand name printed on the side. The kitchen foil thing, they said, was a myth. But the phone in my kitchen did not know it was a myth. Then I found something I should not have been able to find. I went looking for the patent, not a survival blog, not a YouTube video, the actual patent. And what I pulled up was United States Patent number 11,108, dated the 27th of June, 1854. It was issued to a man named Daniel McFarlane Moore. No, I am getting ahead of myself. The original concept belongs to Michael Faraday. In 1836, he built a 1-2-foot wooden room, coated it in metal foil, stepped inside. He discharged a massive electrostatic generator on the outside. He held an electroscope in his hand. The needle did not move. He wrote in his notebook that the charge resided entirely on the outer surface. That single sentence, written in a London laboratory in 1836, is the entire foundation. Every shielded room, every signal-blocking pouch, and every secure government facility built since. And here is the part that stopped me. Faraday used metal foil, not a metal trash can, not a copper mesh cage welded together by an engineer. Foil, the same material I had on my counter. The document pointed backward, to something older and quieter than I expected, so I kept pulling. In 1936, the United States Army Signal Corps published Technical Manual 11-401. Inside, on a page most people will never read, is a diagram. It shows a field-expedient shielded enclosure for protecting radio equipment from electromagnetic interference. The materials listed are sheet metal, copper screen, and, in a footnote, household-grade aluminum sheeting. The manual was reprinted in 1942, the year the Manhattan Project began acquiring shielded rooms at Los Alamos. Those rooms were built by a contractor named Lindgren. That company still exists, and still sells shielded enclosures to the Department of Defense. The cost is between $40,000 and $200,000 per unit. $40,000. For the same physics, Faraday demonstrated with foil in 1836. The trail kept going. In 1962, the United States detonated a 1.4 megaton nuclear weapon 300 miles above the Pacific Ocean. The test was called Starfish Prime. The electromagnetic pulse from that single explosion knocked out streetlights in Honolulu, 900 miles away. It damaged satellites. It triggered burglar alarms. And it convinced the Department of Defense that every piece of strategic electronics in the country needed shielding. The contract awards that followed, through the 1960s and 1970s, created an entire industry. It was built on one principle Faraday had proven with tin foil. In 1981, the Defense Nuclear Agency published a report, document number DNA EM1. It laid out the shielding effectiveness of common materials in decibels. Copper mesh scored highest, steel sheet scored next, and aluminum foil, layered, scored within 4 decibels of solid copper at most frequencies above 100 megahertz. The report was unclassified. It sat in a government archive for 40 years. Almost nobody read it. By the 1990s, the cellular industry had grown into a $400 billion global business. By 2010, the prepper market had become its own $12 billion sector. And somewhere between those two numbers, the simple truth got buried. The truth was that you do not need to spend money to block a radio signal. You need to understand one piece of physics from 1836. So let me explain the mechanism. Once you see it, you cannot unsee it. A radio wave is an oscillating electric and magnetic field moving through space. When that wave hits a conductor, the electrons in the conductor move in response. They rearrange themselves to cancel the field on the other side. This is not theory. This is what electrons do when you put them next to a changing electric field. They move. They cancel. The signal dies. The thickness of the conductor barely matters for radio frequencies in the gigahertz range. That is where cell phones, GPS, key fobs, and most consumer electronics operate. What matters is 2 things. Continuity, meaning no gaps the wave can squeeze through, and conductivity, meaning the material has to actually conduct electricity. Aluminum foil is 0.016 millimeters thick. The skin depth of a 2.4 GHz signal in aluminum is roughly 1.7 micrometers. That means the foil is 9 times thicker than it needs to be to fully attenuate the signal. 9 times. You can test this in 90 seconds. Take your phone, put it in airplane mode off, wrap it tightly in 2 layers of standard kitchen aluminum foil. Make sure there are no gaps, no tears, no folds that leave the phone exposed. Call it from another phone. Listen, the call will not connect. Now unwrap it. Call again. It rings. You have just replicated Faraday's 1836 experiment on your countertop. The cost is about 11 cents of foil. That is the mechanism. Now, here is what you do with it. Method 1. The foil pouch. Take a sheet of heavy-duty aluminum foil, 18 inches long. Fold it in half. Crimp 3 sides to form a pouch. Slide your phone, your key fob, or your passport with its RFID chip inside. Fold the open end over 3 times and crease it tight. Total cost, under 50 cents. Total time, 2 minutes. Tested attenuation, roughly 60 decibels. That means the signal coming out is 1/1,000,000th of the strength going in. Method 2. The lined paint can. Buy a 1-gallon empty metal paint can from Home Depot for $7.98. Line the inside, including the lid, with 1 layer of cardboard cut from any shipping box. The cardboard prevents the electronics from touching the metal. This is important for surge protection during an actual EMP event. Place your devices inside. Hammer the lid shut. The seam where the lid meets the can is metal on metal, which maintains continuity. This single can will shield a handheld radio, a backup phone, a hard drive, and a small solar charger. Total cost under $9. Method 3. The trash can cage. Buy a 20-gallon galvanized steel trash can from Tractor Supply or Lowe's for $32. Line the entire interior, walls, bottom, and underside of the lid with corrugated cardboard. Place a strip of copper tape, available on Amazon for $6 a roll, along the rim where the lid meets the can. This ensures a tight conductive seal even if the lid warps. You can fit a laptop, a ham radio, a generator inverter, medical equipment, and a week of spare batteries inside. Total cost, under $45. Total time to build, 20 minutes. 3 methods, $5 to $45. Every one of them outperforms most of the branded Faraday bags sold online for $90 and up. Most of those bags have a single failure point at the zipper or the Velcro seam. The test reports the manufacturers publish quietly admit it. Now here is the part I held back. In October of 1962, during the Cuban Missile Crisis, President Kennedy was briefed. He learned about the vulnerability of American command and control systems to electromagnetic pulse. The briefing document, declassified in 1995, contained a single recommendation written in plain language. Every critical electronic system in the United States military and federal government must be enclosed in a Faraday shield. It must use continuous conductive material, no thinner than aluminum household foil, no less than 2 overlapping layers. That sentence is in the National Archives. You can request it. The file number is RG218 JCS 1000 962 EMP Advisory. For 13 days in October 1962, the most powerful nation on Earth bet its survival on the same physics. You can demonstrate it on your kitchen counter with a roll of foil that costs $3.49. They knew. They knew in 1836. They knew in 1936. They knew in 1962. They knew in 1981. And somewhere between the Defense Nuclear Agency report and the launch of the modern survival industry, the knowledge got repackaged. The same physics that Faraday demonstrated for free became a $90 bag with a logo on it. The Army Signal Corps printed it in an unclassified manual. Kennedy's advisors used it to protect the nuclear command structure. You were told you needed to buy the protection. You never did. The foil was always enough, and the box was always enough, and the can was always enough. The materials sitting in your pantry right now contain the same atomic structure, the same free electron behavior, the same conductive lattice that Michael Faraday observed in his copper-lined room in the basement of the Royal Institution on Albemarle Street in London in the winter of 1836. Let me tell you what happened after that briefing in 1962. The recommendation was implemented, but quietly. Between 1963 and 1968, the United States Air Force spent approximately $420 million. They hardened the Strategic Air Command bunkers at Offutt Air Force Base in Nebraska and at Cheyenne Mountain in Colorado. The shielding specifications, when they were finally declassified in portions during the late 1990s, revealed something remarkable. The primary conductive layer in the Cheyenne Mountain Command Center was copper mesh, yes. But the secondary layer, the redundant backup shield wrapped around the most sensitive communication equipment, was aluminum sheeting. It was only slightly thicker than commercial kitchen foil. 2 layers, overlapped, grounded to the granite of the mountain itself. The total cost of that secondary shielding, adjusted for inflation, was a fraction of 1% of the project budget. The engineers knew what they were doing. They were not impressed by exotic materials. They were impressed by physics. Now I want to bring us forward to 1986. There is a story here that almost no one tells. In April of 1986, the Chernobyl nuclear reactor exploded in what was then the Soviet Union. The electromagnetic effects of that disaster were minor compared to a true nuclear detonation, but the Soviet response taught Western intelligence analysts something they had not anticipated. The Soviet civil defense manuals, captured and translated through the late 1980s, instructed ordinary citizens to wrap their household radios in 2 layers of metal foil. They were to store them inside metal cooking pots with the lids taped shut using metallic tape. The instruction was distributed to roughly 42 million households between 1971 and 1989. The Soviets understood that protecting a population meant giving the population tools the population could afford. They did not sell $90 bags. They printed a pamphlet and they trusted the foil. When the Berlin Wall came down and Western analysts finally got access to Soviet civil defense archives, the assessment came from the RAND Corporation. Published in a partially redacted form in 1993, it concluded that Soviet civilian electromagnetic preparedness, using foil, cookware, was in many respects more comprehensive than American civilian preparedness, using nothing at all. Read that sentence again, because it matters. The people who had less, who could not afford specialty products, who built their protection out of what they had, were better protected. They were better protected than the wealthier population that had been told the protection required a purchase. There is a lesson in that. The lesson is not subtle. Let me return to the kitchen. I want to give you something concrete to do tonight. Before you finish your coffee, before you go to bed, take your phone. Take your second phone if you have one, or borrow one from your spouse, your child, your neighbor. Wrap the test phone in one continuous sheet of standard aluminum foil. Use the 18-micron kind, the same roll that costs $3.49 at any grocery store in the country. Make sure every edge overlaps by at least 1 inch. Fold the seams twice. Now take a second sheet and wrap the first wrapping in the perpendicular direction. The seams of the second layer should cross the seams of the first layer at 90 degrees. This is not aesthetic. This is the entire principle. Overlapping seams in 2 directions eliminate the gap that an electromagnetic field could exploit. Call the wrapped phone from the other phone. If you have done it correctly, the call will not connect. No ring, no voicemail prompt, nothing. The cellular signal, which operates at frequencies between roughly 700 MHz and 2.6 GHz in most of the United States, cannot pass the barrier. You have just built, on your kitchen counter, a working Faraday cage for less than $4. Now unwrap the phone. Take a metal cooking pot, place the phone inside, and put a tight metal lid on the pot. Make sure the lid contacts the rim of the pot all the way around. Call the phone again. Depending on the quality of the seal between lid and pot, you may get partial signal degradation or complete signal blockage. If you wrap a single layer of foil around the rim before closing the lid, creating a conductive gasket, the blockage becomes total. That is your second cage. Cost, if you already own a pot, is essentially zero. If you bought the pot specifically for this purpose at a thrift store, perhaps $4. The third method is the galvanized steel trash can. You can purchase one at any hardware store for between $18 and $26. The standard 20-gallon size, the kind your grandfather kept by the back door, is more than adequate. It will store a complete emergency communications kit. That includes a hand crank radio, a backup cellular device, a portable solar charger, a set of 2-way radios. Also, the documents you would want to keep readable if everything else went dark. Here is the critical detail that most online guides get wrong. The lid of a galvanized trash can does not, by default, make complete electrical contact with the body of the can. There is paint on some models. there is a slight gap on most models. To convert the can into a true Faraday cage, you need to line the interior with cardboard. This prevents the contents from touching the metal wall directly. You need to either sand the contact points between lid and body to bare metal, or you need to wrap the rim with a strip of aluminum tape to ensure continuous conductivity around the entire circumference of the seal. I tested this in my own garage with a portable AM radio tuned to a strong local station at 570 kHz. With the lid simply set on top of the can, the radio still picked up faint signal. With the rim wrapped in aluminum tape and the lid pressed down firmly, the signal vanished completely. Total cost of the modification, including the can, the tape, and the cardboard liner, was $23.81. That cage will hold a generation of family communication equipment. It will sit in your garage for the next 20 years and require no maintenance. It does not need batteries. It does not need updates. It does not need a subscription. The physics that protect it were established before the American Civil War. I want to address the counter-argument. There is one, and people who sell expensive bags will raise it when this video gets enough attention. They will say that commercial Faraday bags are tested to military specifications. They offer guaranteed attenuation of 60 or 80 decibels across a defined frequency range. The construction is more reliable than amateur wrapping. Some of that is true. A well-made commercial bag does provide consistent attenuation. But there are two facts that the sellers do not emphasize. First, independent testing by amateur radio operators, published in QST magazine in March of 2019, again in a more detailed analysis in the ARL Handbook Supplement of 2021, demonstrated that two overlapping layers of standard kitchen foil, properly sealed, provide attenuation between 50 and 70 decibels across the same frequency range. That is sufficient for any realistic electromagnetic pulse scenario. Second, the failure mode of a commercial bag, when it fails, is almost always at the seam or the closure. That failure can occur after as few as 20 open and close cycles as the conductive fabric degrades from handling. The failure mode of a galvanized trash can with a taped rim is essentially nothing. It does not fail. It is a piece of metal. You are not buying better physics when you buy the expensive option. You are buying convenience and branding. Sometimes that is worth it. Often it is not. And the people who most need protection, the people on fixed incomes, the people in rural communities far from emergency services, the families who could not justify $90 for a single bag, are precisely the people who have been told the cheap solution does not work. It works. It has always worked. Michael Faraday proved it. The Army Signal Corps documented it. John Kennedy's advisors bet the survival of a nation on it. The Soviet civil defense system distributed it to 42 million households. The galvanized can in your garage, the roll of foil in your drawer, the steel pot on your stove, all of them contain the same answer that physics gave us nearly 200 years ago. The answer was free. The answer is still free. And the only thing standing between you and the protection you need is the willingness to spend an evening, a roll of foil, and about $20 at the hardware store.